All right, we've been talking about the area. We've started. We've been talking about the area, okay, and yesterday we talked about the surface area of a what? Prism, okay. Remember what a prism did? It had a base, and I'm not gonna. And then they had another base on top, right? So it had bases, and the sides went straight up, didn't they? All right, so they were perpendicular. So the sides are perpendicular to the base. All right, that's a beautiful drawing. Yes. What we're going to do today is we're going to talk about another figure, not a prism, but it also starts with a P, and that would be a pyramid. All right, so we know about pyramids, right, in Egypt and all that kind of stuff, and we're going to talk about different types of pyramids. So we're going to find the surface area of a pyramid. All right, so what in the world is a pyramid? Well, let's take a look. I did this in my other class. Let's see if I can find it. Aha, where did I put it? There it is. That's what I want. All right, here's a pyramid. Now, pyramids can have different shapes of a base. To tell you the truth, I'm not really sure. I think in Egypt, I think they're rectangular pyramids. I think the bottom of the pyramids are rectangular. I'm not positive about that. We could probably look it up sometime. Not today. But anyway, that's a pyramid right there. And what we're going to do is we're going to talk just about regular. Actually, let's slide that in there. Let's talk about a regular pyramid. Get rid of that. Now, we know about a regular polygon. So regular polygon means all the sides are equal to each other and all the angles are equal to each other. Okay, so when we talk about a regular pyramid, we're talking about the base is a regular polygon. So in this case, it's a four-sided figure. So what's a regular four-sided or regular quadrilateral? It's a square, isn't it? Okay, so this would be a square. That means at the corners right here, it's a right angle. I know it doesn't look like a right angle because the reason is because they had to make it three-dimensional. When you make it three-dimensional on two-dimensional surface, you kind of have to slant things, right, to make it have that feeling of three dimensions. So even though it doesn't look really perpendicular, like it hits at a right angle, if you look at a certain angle, right, it is perpendicular. You've seen that before, haven't you, when you see three-dimensional drawings? Okay, so they are perpendicular right here. But you got a couple other things. Look at this. There's not two bases. There's only one base because these sides don't go perpendicular. This side right here, you see that edge? We call that the edge. We call the front part of this the face, and this is the edge of the face. That edge right there is not perpendicular to the base. Do you see that? It slants. So look, if you had, here's your base right here, and if it's slanted like this, this right here is not perpendicular to the base. Make sense? All right, so it doesn't go straight up in the air, and so you don't have a base on the top. And in fact, it just comes to one point at the top. So that makes it a pyramid and not a prism. A prism goes straight up. It's flat on the top, flat on the bottom. Everybody got that? But this is not a prism, it's a pyramid. And from time to time, I'll probably mix up the two as far as the word. Since they both start with P, sometimes I'll be talking about a pyramid and I'll say prism. And sometimes I'll be talking about, I think I might have done that yesterday. I think I might have said pyramid, or in my other class, maybe I did. But I'll try not to. I mean, I know the difference between the two. Sometimes I just get mixed up a little bit. All right, so anyway, look at this thing right here. This thing right here is a base. And what kind of base is this? It's a square, right? So I should know how to find the area of the base. So for this particular one, what would the area of the base be? We'll put B for base. The area of the base would be what? Base times height, right? Okay, so now they use S for side, right? I guess you could do that as well. It'd just be side squared, right? Or this is base, this is height. They're going to be the same thing because it's a square. But then we got to find everything around it. What did we call that yesterday? Well, no. Everything around it. Lateral surface area. That's right. It's called the lateral surface area. Now, our formula for lateral surface area is a little bit different. Because look at the sides. Look at the faces. Yesterday, all the faces were rectangles. You remember that? Because when the sides go straight up, every face is going to be a rectangle. But the faces are not rectangles on this one. What are the faces on this one? On the pyramid. What kind of shape are the faces? It's a triangle, right? It's a triangle, the face, right? What you're looking at, right? Like right here, and right here. What are they? It's a triangle, isn't it? Yeah? Do you not see that, or just not answering me? Okay. So the face is a triangle. So instead of saying for the lateral surface area, let's draw a color I can see now. So if I do the lateral surface area of a pyramid, what did we say it was on a prism? We said it was the perimeter what? Yeah, it was but the lateral surface area was what? It was the perimeter of the base times the height. Why did we do that? Because it was always a rectangle. All the sides were rectangles, so it was base times height, wasn't it? But it was all the bases, right? The perimeter of the base. So we added up all the bases multiplied by the height, and that gave me everything around that prism. But this time, it's not just base times height. What is the face of this thing? It's a triangle. So what's the area of a triangle? It's 1/2, right? The base times the height. But let's think about this. Let's go to, let's make this a little bit thicker right here. Watch this. I'm going to try to highlight this so you can see which triangle I'm talking about. Right there. See that triangle right there? It's kind of off to the side a little bit, but I'm looking at that triangle. So if I take a look at one of the faces, I could have done that to the front, but they've labeled this side right here, so that's why I did this. When I'm going to find the lateral surface area, oops, sorry, let me get back to where I was. There we go. If I want to find the lateral surface area, I'm not going to just take the perimeter of the base times the height. I'm going to take 1/2. What do you think? The perimeter of the base, and I think they call that P for perimeter of the base, times the height of that triangle. Well, what letter describes the height of the triangle? Does H describe the height of this blue triangle that I've kind of highlighted? It's what? That's an L. Yeah, that's an L. It's kind of weird looking, but it's like a cursive L right there. Now that L right there is called the slant height of that triangle. Okay, it's called the slant height. So L represents for that red right there. Everybody see that red? I'll darken it in a little bit. And watch this. So there to there. That's pretty good, I guess. See that red one? Okay, that's the slant height. So like if you were able to sit on top of this thing, all right? It's a little pointy up there, but let's pretend you could sit up there, and if you wanted to slide straight down the middle of it, then that would be the slant height. Everybody see that? Because it's the height of that triangle. If I was to take that triangle and redraw it, it would kind of look like this, wouldn't it? Everybody see that? Okay, so it's not the height. It's not the base times the height. It's 1/2 the perimeter of the base times the what? Slant height. And the slant height is represented by the letter L. Alright, so it's 1/2 PL. I guess I could have kept that color coordinated here, couldn't I? What's that? PSL? I don't know, because L is the slant height. Because L, I said, L right there. It's right in front of you. L equals the slant height. They just use L. Okay, I don't know why. They just use L to represent the slant height. Make sense? I mean, who cares why? They could have used Q. I mean, who cares? It doesn't make... I'm not asking you, do you understand why they used L for the slant height? That's not the question. The question is, do you understand that L represents the distance from here perpendicular to this side right here? Okay, that's the slant height. Do you understand that part of it? Okay, whatever. I don't care.
These drawings are so annoying.
I am. I'm just...
That's why I don't do it.
Put yourself in my shoes. All right. So that's how you find what? That's not the total surface area of the thing. That's just what? That's just the lateral surface area. So if I wanted to find the total surface area of this pyramid, what would I do? I'd find the area of the base and then add it to the lateral surface area, which would be what? 1/2 the perimeter of the base times the slant height. So that's the new thing right there. Okay, so right there, that's the total surface area of a pyramid. Now, the area of the base could be very easy, like this one. Or it could be a little trickier because they could give you the base as a pentagon or a hexagon or an octagon or a decagon or something like that. And then you'd have to be able to figure out what the area of that base was. So sometimes it's not going to be quite as easy as this particular picture. Sometimes they're going to give you a base that maybe not, isn't so easy to find. But we've already talked about that. We had a chapter, didn't we? Didn't we just finish doing a test on finding the area of regular polygons and stuff? Yeah. So you got to refer back to that kind of stuff. So there you go. So that's how we find the total surface area of a pyramid. Does that make sense? What does the height do? The height of this pyramid. It's from the very top. A lot of people say straight down to the bottom, but what? Perpendicular to the base, right? This is the base right here. So if I had a pyramid, I use this example in my other class. When I think of these pyramids, I think of the Indiana Jones movies. You ever guys ever watch the Indiana Jones? They were big when I was in high school because they were out in the theaters, and it was like one of those deals where like Harry Potter. You can't wait to go out to the next Harry Potter. Well, I'm not a Harry Potter person, but I was definitely an Indiana Jones person. I couldn't wait for the next Indiana Jones movie to come out because I wanted to go see it. And that was like the action thriller movie. Well, in the first movie, he actually is on top of this pyramid, and they're kind of excavating and stuff like this, and he goes down on a rope, and what are at the bottom? What's meeting him down the bottom of it? No alligators. Nobody's seen this. There were snakes because he hated snakes. He wasn't afraid of anything else, it seemed like, but he hated snakes. And what was down here? It was completely because I think they put a flashlight down there or a lamp, and they're like, why is the floor moving? And then when they got down there, they figured it out because it was completely filled with snakes at the bottom, and so that was pretty interesting. But anyway, watch. What is the distance that he traveled? He traveled the height of that pyramid. He went from the very top, perpendicular, to the base. Now, if this is a regular pyramid, that's going to be right at the center of the base. All right. So if we had a pentagon or something like that, or a hexagon or octagon, this would be the center, and then you could figure out apothem and all that other kind of stuff. All right. Yes.
You see the latest Indiana Jones movie with all the army ants?
No.
That was pretty G.
Good. All right. All right. Let's pay attention up here. Let's do this. Let's do this thing. It's a nice, pretty picture, isn't it? I didn't draw it. It is. Looks like a dunce cap, okay, or an ice cream cone, upside down ice cream cone. This thing right here is just called a cone. So we're going to do, this is the surface area. We're going to find the total surface area of this thing, and this is called a cone. It's basically a pyramid with a circle base, isn't it? All right, because it all comes up to a point, just like those pyramids did, but the base of it is a circle. Remember yesterday we said for some reason they like to give circles special names, like the perimeter of a circle, they give it a special name. They call it circumference. They don't just call it perimeter, do they? All right, so same thing with this. What was the other thing? A cylinder, right? Instead of calling it a prism, a circular prism, they give it a special name. They call it a cylinder. Well, this thing right here, they give it a special name. Instead of saying this is a circular pyramid, they give it a special name, and they call it a cone. All right, and you know that, ice cream cone and all that kind of stuff. All right, so let's figure out how would we find the area of this. Well, first of all, we find the area of the base. I'll just put A, the area of the base. All right, that would be easy. So what equation would give us the area of the base? Pi r squared, because it's a circle, right? So the area of this is a circle, plus. Now here's the part that you don't really know yet. If I wanted to find the lateral surface area, so it's the area of the base plus the lateral surface area. Here's a little formula for lateral surface area of a cone. You writing this down? It's pi r L. L is, again, the slant height, just like it was before. So it's just pi r L. There's no half in this one. Okay, it's just pi r L. So if I wanted to find the total surface area of this cone, I just find the area of the base, which is a circle. Then I find the area of the lateral surface area of all the sides, right? Which would be, it's real smooth, right? You know a cone, right? So it's real smooth, and it's just pi r L. Well, no, it's a smooth cone, all right? It's like, Back when I was a kid, we'd go to vacation Bible school, and they would always give us snow cones. You ever eat those? Where you know the
Except for the ones like at the
or the
store,
or the little
it just tastes like
or the little cone that you get. You know, you go to a water tank. What do you call that thing?
Water fountain?
No, not a fountain.
Oh, I know.
Where you push
Oh, the water,
No. Where
the
you,
water dispensers.
yeah, you push the button and yeah, you see the water on top. What do they call it? Like a
A water.
Oh, water cooler.
dispenser.
water cooler. They call it a water cooler, right? And so, but usually they come with little cups, right? And you pull them down, and usually little cones, aren't they?
Those ones are
And
skinny,
that's
you can't put them
that's
down.
what it is. Okay, so that's a cone. Pi r squared. Yeah, they are kind of a pain because if you're
I like crushing them.
you got to drink it all at once. I guess it's not that hard though because they're always real tiny anyway, aren't they? But you're right. You couldn't just put it down and wait till later because you can't sit them on anything, can you?
You guys
All right.
on something.
So anyway, there you go. So that's how you find the surface area cone. Not too hard. I don't even think I have to go through any examples on this at all. So you find the area of the base. This is the lateral surface area, pi RL. Remember, the L is the slant heights. This height right here. It's not the H. It is not the H. Yes. Because we're going to do volume a little bit later, and we're going to talk about the H, okay? So right now. Now sometimes, look, sometimes they'll do this. Sometimes they'll give you the height in the problem, and they give you the radius. But you still have to find this. So how would you find this if they give you the height and they give you the radius?
The Pythagorean.
Pythagorean theorem to find the L. Okay, so they could give you the height, even on the surface area stuff, but you're using the height to figure out what the L is. Okay, same thing with this too. All right, they could have given you. Now watch this. Sometimes this is a little tricky. What if they give you the height and they give you the length of this and they ask for the slant height? Could you find the slant height if they tell you one of the sides and they tell you the height right there? That's right, half of S. That's right, exactly right. Let's do this in another color. What haven't we used?
Green.
Green. Let's use this
Use
green.
invisible colors.
Dark green. Watch. So where would that would go to here, wouldn't it? Everybody see that? So that, let's make it a little thicker. Used to be a commercial back in the day. I think it's what it was. Kid would say thickerer. You ever hear that?
Oh, yeah, that was
Okay, so watch. What if they give you the height? What if they give you the height and they just give you the length of this side? Well, this thing right here would be half of the side, wouldn't it? All right. So if this was 8, then this would be what? 4. So you take the height and this little length right here, Pythagorean theorem, you can find the L. So you really have to use your imagination sometimes on these pictures, right? Because it is three-dimensional, right? So you kind of have to look inside to figure out what's going on. Make sense? All right. I think we covered everything. I didn't really do an example, but I think we're fine with that. You can look in the book if you want to see. There are a couple examples in there, but you can look at that. I think just understanding what these things represent and how to find them, it's 1/2 the perimeter of the base times the slant height. That's the lateral surface area, remember? Okay, and then you find the area of the base. You don't have to double it like you did with the pyramid, did you? There I go, I did it. Like you did with the prism, all right, because there is no 2 bases. There's only 1 base. So really, what's the only thing really new we learned? This and this right there. Okay, that's it. Let me give you some problems to do.
Let's not say we did.
Let's
I
just
like
say we
anti-
did.
Yeah, let's say we did.
You know how close? You know how close I am to giving you work from the book and a worksheet? Because I have 12.4 worksheet sitting right here, or 12.3 worksheet sitting right there. So if you ask me again to give you less problems, I may just
Can you give us
help
some
you
more problems?
out.
No.
Why don't you just not say anything? No, it's not going to work. Because I know you're being sarcastic, I know you're being silly, and I'm not really appreciating that at the moment.
I don't love you.
So let's go to let's go to 17. What did I give the last class?
I like the
I think I said 19.
I like the odds.
I think I said 19. I don't have it written down, but I think I gave you the 19. All right, and guess what? We're doing all. I was going to give you the odds until everybody's asking for. Not really. I was going to give you the all anyway, but it's going to make you feel bad. Okay, so there you go. You're doing all of it. 7 to 19. There's the page. There's the lesson. That's due Monday. If there is a Monday, who knows? We'll see.
It'd be funny.